Hi, we're going to finish the chapter today with lesson 9.4 and 9.5. Now, 9.4 stuff that we've already gone over. We did it the Core 40 way, and now we're just going to add the two theorems that your textbook talks about. So, Theorem 40 just says the area of a parallelogram is the product of any base and corresponding altitude. And we've already talked about this formula. So area is base times height, because we understand that altitude is the same thing as a height. Okay, and for theorem 41, again, we've also talked about trapezoids. The area of a trapezoid is half the product of the altitude, which again is height. Pin won't function. And the sum of the bases. Okay, so 1/2 times the height times the sum of the bases. Now, we also talked about how you can rewrite it a couple different ways. They all mean the same thing. It's just whichever way you prefer. Okay, so we already talked about these, and now, you just have the theorems. Okay, now we do need to talk about Pythagorean again, and whenever you are referencing the Pythagorean theorem, it is theorem 42, or you can just say the Pythagorean theorem. Written out, it says the square of the hypotenuse of a right triangle is equal to the sum of the squares of its legs. So we probably know it better as a squared plus b squared equals c squared. A and b represent the legs, and c represents the hypotenuse. And just to make sure we're all on the same page, you have the right angle straight across. This is your hypotenuse. And then the two legs are the two sides that form the right angle. Now, I'm not sure if you guys know, but my favorite movie is The Wizard of Oz. And I have a clip for you from The Wizard of Oz, if I can get it to work. Maybe not. Yeah. Let's try one more time. Where is the link? Okay, I want you guys to tell me the error that you see.
Where I come from, we have universities, seats of great learning, where men go to become great thinkers. And when they come out, they think deep thoughts, and with no more brains than you have. But they have one thing you haven't got, a diploma. Therefore, by virtue of the authority vested in me by the Universitatis Comitiatum e Pluribus Unum, I hereby confer upon you the honorary degree of Ph.D.
PhD?
That's Doctor of Thinkology.
The sum of the square roots of any two sides of an isosceles triangle is equal to the square root of the remaining side.
Okay.
Oh, George, I've got a brain. How can I ever thank you enough?
Well, you can't.
All right, did you guys catch the error that happened?
Writing's not that easy, but Grammarly can help.
Okay, so hopefully you caught the error. So when the Scarecrow got his Doctor of Thinkology, he what was supposed to be the Pythagorean theorem, but he said a major error. Did anybody catch it? He said it was an isosceles triangle. And it doesn't have to be an isosceles triangle. It has to be a right triangle. You got it. Okay, now we need to talk about the difference between theorem 42 and 43, because every year this is a major hang-up. Okay, so let's read 43 and talk about the differences. So this is the converse to the Pythagorean. If the square of one side of a triangle is equal to the square of the sum of the other two sides, and the triangle is a right triangle. We use theorem 42 to find a missing side. Okay, so on this picture that I drew, if I gave you a problem like, hey, this side is 3 and this side is 4, find x, you're going to use theorem 42 because you're going to find a missing side. But if I give you a triangle and I say this side is 3, this side is 4, and this side is 5, is it a right triangle, you're going to use the converse to show if it works or not. So you would take the two sides that would be the legs and you would square them, and it would be equal to the hypotenuse squared, and you would see if the left side equals the right side. So let's test it. 9 and 16 is 25. And so since 25 equals 25, you'd say, yes, this is a right triangle. But if I had another triangle where I have 3, 3, and 5, and I know it's not to scale, we're going to ignore that fact. 3 squared and 3 squared is 5 squared. So is 9 plus 9 25? No, because 18 does not equal 25. So this is not a right triangle. So we're trying to determine if it's a right triangle. So write yourself a note. Use to determine if it forms a right triangle. You have to know all three sides, okay? For theorem 42, you only know two sides. So there is a big difference, but every year people get these confused, okay? Now, this is a representation of the Pythagorean theorem. So if I square A, if I take the segment square, it actually makes a square, right? So let's use the same numbers again. So if this is 4, and then it turns into 4 times 4, that's why this is 25. And then this side is 3, 3 times 3 is 9. The idea of this is that the number that's on the inside, A, because we know the formula, right? A squared plus B squared equals C squared. This A has already been squared, and this B has already been squared, so it's going to equal this C. So it's 25 plus 9, it's 36. So the idea of this is I could just give you 36 here, and let's say 3 here, and you could figure out the rest. So to go from big C to little c, you would square root it. So the square root of 36 is 6. Oh, why did I say that? Let's back up. Sorry. 25. The square root of 25 is 5. And then for big B, you would square it and get 9. And then you would do Pythagorean and get this little a is 4. And then you would square the 4 to get big A is 16. So that's the way it works. Okay. And yeah, same numbers. I use the same numbers every year. Okay. So that's the old assignment. All right, guys, that's it for the lesson. Please message me if you have any questions.